In this video we are going to go over the power operator, not the power function, the power operator. So if you are familiar with the power operator and how you can use it for repeated function application, feel free to skip this video. Otherwise, if you'd like to review that, or if you've never heard of the power operator, let's get straight into it, and then, not then. So what we are going to do is show you how the power operator that you can type with APL Shift E, as in power, can be used to take a function on the left and an integer on the right, and then apply the function f k times to whatever value you have here. So f0 val, okay, so applying f0 times to val should leave val unchanged, right? So this returns val. If you have f power 1 val, this should apply f ones to val. If you have f power 2 val, then you should get f of val, and so on and so forth. And the power operator is much more powerful than this. Okay, you can give it negative integers, and then it will try to apply the inverse of f, and you can even use other functions here. But that's beyond the point of this specific video, and so we'll stick with non-negative integers. Let's say you watched the previous video and we want to define this increment function that is the plus function carried with a 1. So that increment on a number gives you the next number. So if I wanted to increment this 5, I don't know, 6 times, I could type inc 6 times in a row, but this is terrible, terribly boring. And so what I can do is use the power operator to apply the inc function 6 times for me. And there you have it. And notice that I had to use parentheses. If I just type in this, again, APL stranding is taking these two numbers and seeing them as a single array and giving them as the operand, as the right operand to this power operator. But that's not what we want. We just want the 6 to be given as the operand, and so you have to parenthesize the expression. And there you have it. This gives you repeated function application. An interesting usage of this operator is you can use it to perform conditional application of a function. Notice here that f power 0 in a number leaves the number unchanged, and f power 1 in a number does something to the number. So sometimes you'll see code that has some conditional expression, which is a Boolean check, I don't know. Let's say we want to define this function that squares the number if the number is negative, I don't know. And so you can have this square if negative thing, and what we will do is square the number. So this is the square function, and we want to square it only if the number is negative. So we could have here omega smaller than 0. Oops, okay. What this is doing is I'm checking if the number, sorry for that, I'm checking if the number is smaller than 0, and if it is, this evaluates to 1, and I will apply the function on the left once. But if it's not, this evaluates to 0, and so I don't want to apply the square function. And now again we have to be careful with stranding, because as is, this will be seen as a single array. So I have to wrap this in parentheses. And now I have my square if negative function. Let's say minus 2 gets 4. Square if negative 2 stays 2. There you go.